So today we're going to be looking at computer networks. And the first question you should ask yourself, what is a computer network? Before we maybe go further, we should know what exactly a computer network is. So a computer network, this is just a group of interconnected computers. So interconnected either through the wires. These are usually either wired or wireless. So interconnection through wired, these wires are the Ethernet cables or the optical fibers or the coaxial cables. It can also be through wired, the wireless option. The wireless option mostly is through the radio telecommunications. So, and so as per the definition here, is a group of computers that use a set of communication protocols. The protocols here are rules, right? So these rules, there must be rules, of course, governing how messages are communicated. So for those of you who are going to continue the IT, maybe this one may come later. We look at various rules. How are these rules used to govern this communication? Then over digital interconnections, again, these interconnections I've said can be through, it can be wired or wireless. Wired, we provide the options for the Ethernet cables, the optical fibers, and the coaxial cables, another wired connection. All can be wireless. Wireless can be through the infrared, like the remote. You also been using the remote. You can also download the app maybe and put in your phone and the remote app. You can be using that one as a remote, or through the radio waves or the satellite communication. So these are the interconnection you're talking about. So why do we have the interconnections? So for purposes of sharing resources. So located or provided by the network nodes. So which exactly are these resources? So these resources could include the softwares, the printers. I think you have an example in a diagram here. So Victoria Mwima, you're asking, you said you do the card before next week. No, the card is going to open next week at 8, right? So the card is strictly 1 hour. So it's not open like the entire day or the entire session. So the card is strictly 1 hour. It is comprised of 2 sections. Section A, which is multiple choice. Section B, which is essay questions, where you have to answer on, you can either choose to type or rather to write in your, maybe let's say you write on a book or somewhere, then take a screenshot or take a pic of the same and upload, or I'll provide an editor where you can just type in, right? So there are those two options. So the card is not open, to just open between next week 8 and it will close at 9, right? So that one is timed. Now, from our presentation here, you can see that there is a network diagram, and it is simply illustrating the definition of what you just talked about. So we have defined a computer network as simply the interconnection, a group of connected computers. And I've said that the connection could be either wired or wireless. So you can see that we are connecting to here. This one is wired here. And you can see that this indicates that the connection is wireless through an access point. So the access point again is connected either to a modem or a router. Maybe the most basic and simple network is as illustrated on the image on your right. So if you want to access the internet, of course you have to go through an ISP, right? So ISP stands for the Internet Service Provider. So these days you have so many ISPs. So an ISP could either be Safaricom, maybe Zuku, maybe Cybernet, maybe there are so many other providers depending on whoever you choose. So from the provider, you can connect either, there's an option for connecting through wired or wireless. So the ADSL and the cable or fiber or wireless, these are the interconnection. These are the interconnection you are talking about. So you are either connected through the wired connection or wireless connection. Then when you get to your home, this router here is called at your home, right? I know most of you may be having routers at your homes, or maybe you've ever gone to a cyber, you see a router somewhere. So the ISP, the connection, the cable from the ISP connects to a router at your home or whichever other place, at your businesses or elsewhere. So the moment you connect to a router here, then it is from your router that now you can connect your device. If it is just maybe let's say a home network, the router, most of them, maybe you can take the simple routers like the TP-Link or the D-Link or rather whichever routers you have. It is from here that you can now connect your devices. Again, the router provides two options. You can have the option for the wired. Wired simply means that you're connecting a cable from your router to your devices, either be your laptop or your desktop or whichever other device. It also provides an option for the wireless option. That's why you have the antennas, right? So to broadcast that signal, we call it the SSID. The SSID is the same thing like in your phone. You are hotspotting, right? So when you hotspot, you broadcast a wireless signal. So a router here can also broadcast a wireless signal, as you can see here. So a wireless signal is received by either a laptop or your phone or any other device that can access the wireless connections. The wired connections here, mostly we use CAT. There is CAT 5. CAT 5 stands for category 5. These are Ethernet cables. Category 5 or category 5E, that is category 5 extended. Category 6, again, the difference between these ones is the speeds, right? So category 5, 6, then there is also category 7. I think it is in draft form for now. So this is a simple diagram illustrating the definition of what a computer network is. So right now, we're also using a computer networks, and it is very important that it has come to this point that at least you're now doing it practically. You may not understand whatever is going on. Maybe you're just hearing my voice, but you're wondering, you're just maybe in your bed or in your house or wherever you are. But I can able to see you people chat. Some of you, I can hear you talk. You can hear me talk, right? And you can share all these. So this is one of the most important uses of a network. Sharing of what? Resources. So these resources, and we can see one of the resources here could be a printer. So you can be sharing printers over the network. For instance, there is a way you can print wirelessly from wherever you are, maybe using my printer at TZ. Alternatively, at least we are using, I think should come to the next slide of the use of computer networks. Now, before we come to that, let's look at some components of a computer network. Some of them were just discussed. Some of the components of a computer network are here. And there is something I would want you guys to go and check in your notes. I realized that there was some sort of a mistake. There is a similar diagram to whatever you have on the left, but instead of the network interface card, it is written national interface card. There is nothing like national interface card in computer components, network components. So I don't know how you're going to change that, but take note. In your notes, it is indicated as national interface card. So there's nothing like national interface card. It should be network interface card. So on some of the components of a computer network, so if we are saying that we are creating a computer network, what exactly is in this network? How can we know that this is a network, it's a computer network? So these are some of those components. There must be a network interface card, right? Let's say, for instance, your laptop. From your notes, I've included those images, right? And sometimes it's always very good. I usually encourage, make sure you learn using images. It's better to visualize something than just to cram a name that you don't know what exactly the other one is. So a network interface card, they're usually of three types, right? So the network interface card that you connect to a laptop, so you can have for your laptop, network interface card for your laptop, a network interface for a desktop. Desktop for the laptop is usually just one type. So if you open your laptop, there is a wireless network interface card. Remember, I said there are two connections. The network could either be wired or wireless. So if it is wired, the network interface card for the wired connections is different from network interface card for the wireless. And that's why from the image in your notes, you're going to see that. So for a laptop, it's just a small one. If you know how to open a laptop, or maybe you go to somebody who can guide you how to do it, you're going to see as per the image in in your notes. Then the desktop can also have an interface, a network interface card. And the network interface card, you usually see that you can connect an Ethernet cable, right? So at that point where you connect the Ethernet cable, whatever you're connecting to is what we call a network interface card, right? Remember, you can also make your desktop to access the wireless network. Normally, desktops do not have the options for connecting wirelessly, but you can have a desktop wireless network interface card. They usually have antennas. So if your motherboard has a slot for the same, you can connect. Alternatively, you can just buy a USB dongle and you connect to your desktop and it's able to connect wirelessly. So that is what we call a network interface card, both wired and wireless. For the wireless, for desktops, there is the wireless option and there is the wired option. Now, I may not discuss so much about the hubs. They are almost becoming obsolete. Actually, if you go to any shop out there that sells computer, maybe network resources like these ones, you're not likely to get a hub. Though it's been used in the past, maybe you're going to read about it. I may not discuss about it so much. Then you have switches. Again, from your notes, there is a diagram of a switch, right? An image of a switch. You can as well Google, there are different types of switches. The switches go as per the ports. Then we have the modems. Modems mostly are, sometimes the ISP provides the modems for connection to that. We are going to see how this one is used. Then you have the routers. So we may connect using the routers or firewalls. Mostly work the same way, mostly but for small businesses like a cyber cafe, you may not need a firewall, you just need a simple router. Then you have the cables and connectors. So these cables could be the Ethernet cables. So remember, we have said that the Ethernet cables here, we could serve, they usually have several types. Category 3, though they're not usually used category 3 and 4. We have Cat 5, but mostly now we use Cat 5E, Cat 5, Cat 5E, Cat 6, and all different types are based on different speeds. Then you have the fiber. I believe you've all heard about the Safaricom home fiber, right? So all these cables being laid on the roads, alongside the roads, and coming to your apartment or your homes or wherever you are. So they use the fiber. Then you have coaxial. The coaxial cable mostly are used by Zuku. So they either provide the services for the internet or the TV. So these are the cables, the connectors. The Ethernet uses what you call RJ45. So RJ45s are the connectors for the Ethernets. Then you have connectors for each and every cable here. Then where is each component of the network used? So on the right side is again an illustration of where we use each component. So we have the internet here. So from the internet, you contact your ISP. So the ISP is here, the internet service provider, maybe the Safaricom or whichever other provider. You have heard that maybe there is advertisement by Safaricom that if you want to have a home internet, they are providing the routers for free and installation for free. So during installation, they provide a router, right? So this is where you interface with the ISP. So that is where the router comes in, right? For bigger enterprises like, let's say, the ZTech and College University or other universities, we may use a firewall or a router at this point. So a router is going to, there are several functions of a router, and I think I've also indicated that one on your notes. Why do we need a router? What is it used for? So it is at this point that you use a router. So you can either directly connect to a client to a router. A client could be now your laptop or your desktop or your phone. Remember, a router also broadcasts wireless signals, right? So it will depend. You may have routers from TP-Link, D-Link, Huawei, Cisco, right? So ranging from the small for small networks to the big ones. So you may directly connect for home, you can directly connect to a router, either through wires, wired or wireless. Then from here, mostly usually go to mostly what's commonly is the switch, right? So usually come from the router to the switch. So it is from the switch that you can connect now several clients or several desktops or several laptops. The switch usually have several ports. right? So mostly the routers have limited ports. Let me take an example. It will depend on the type of router that you have. Let me take an example of a simple router, maybe that you maybe ever come across with, the TP-Link. If you buy a simple TP-Link router, it usually has 4 ports, 4 Ethernet ports. One port is usually for connection to the ISP. The remaining 3 ports are where you connect your clients. But assuming you have like a cyber where you have like, let's say 10 desktops that you're connecting to the router. Now that the router has a limited ports, that's why we need now what? A switch. A switch is just to increase the number of users that can be connected. Remember, a switch also has ports. I think the smallest switch is 4 ports, right? And they usually go from 4, then 8 ports, then 16 ports, and then 24, and then 32, and then in that order. What ports mean? These are simply these places where you can connect your using an Ethernet cable, like your laptop or a desktop. So 4 port means you can only connect 4 devices. 8 ports means you can connect 8 devices in that order. So depending on the number of devices that you want to connect, now you go with the respective number of ports in a switch. So from the switch now you can connect the 8 devices. Remember the clients or the desktops are also part of a computer network. Now from here you can connect now any other device. You can connect a printer. You can connect maybe repeat or not mostly at this point. You can connect servers. You can connect scanners and other devices. So this is just a typical representation of the components, right, on the left here, and where each component is used, right? So remember, all this connection can either be wired, like in our case, wired using Ethernet cables or optical fiber or other kind of wired connections, or wireless. So those two options are broad. Those are the two broad categories of the transmission medias. Now let's go next. And you have a question, you can always ask. You can unmute yourself and ask, or you can type in the public chat. And again, if I move too fast, you can also comment on that. Somebody is asking, what is the function of a repeater? A repeater, mostly we use it to amplify the signals. How is it used? Let's say, for instance, we have a router. This router is within a building. Let's say you are inside your house. Let's use an example of wherever you are. You have connected a simple router inside your house, but then you have moved out of the house, and as you go further, the signal weakens, right? So as you go further from the router, the signal keeps on weakening or degrading. So that's where we need a repeater, right? So it will take the weak signal and amplify it, then retransmit it, right? So if the range of this router, let's say it's 10 meters, the signal is only strong up to the 10 meters. That means if you go beyond the 10 meters, the signal will either be very weak and you cannot maybe connect the network. So what do? You connect a repeater. So it is going to take the weak signal, amplify it, and then retransmit maybe for another 10 meters. That's the purpose of a repeater. Now, and you should know the function of each component of a network. And from your notes, the notes in the PDF in your portal, you're going to see provided some simple images. You can as well Google all these images so that you see exactly what we are talking about. Now, let's look at some of the uses of a computer network. I think now this has become so basic because for now, we're already using a computer network. So there are several industries that use the computer networks. So some of the basic uses here include the resource sharing, right? So what is being shared? You may share programs or softwares. You can share printers. You can share the data, right? So data maybe you can share via maybe email or WeTransfer or whichever other medium. So these resources, for instance, let's say you've ever gone to a cyber or a computer lab. Inside a computer lab, we usually don't have a printer for every computer, right? So instead, we just network and make every computer inside that cyber cafe or that computer lab or whatever enterprise you are in to use just one single computer, because it will be again too expensive buying a printer for every maybe laptop or desktop. That's why I have it there. So these are the resources we are talking about. Then a communication medium. Communication may be mostly through the email, the social media, and just like we are doing the e-learning, we also communicating through the computer networks. We also have the e-commerce, varying from Amazon, Jumia. Most of you do the online purchases and everything. By then, you're still utilizing what you call the computer network. On your right here, there's a simple diagram or illustration on where the computer networks is used. So the internet, this is the widest network, computer network. The network, we usually refer to it as networks of networks, where devices, millions and millions of devices are connected all over the world. So that's why we call what? The internet here. We have the banks. Of course, I don't know whether you guys have ever gone to a bank and created an account. The bank, the infrastructure of a bank. Let's say you have deposited money. Maybe let's say you are in Nairobi, then you go to Mombasa. Doesn't mean that you can only withdraw your money from the point where you deposited. So those banks, those branches of all the banks are usually interconnected through a computer network. We have the telecommunication systems, the cellular systems, the mobile phones, right? So like the online platforms that you are using. So these telecommunication systems also use what? The computer networks. Otherwise, were it not for the computer networks, even the class for today, the virtual class for today, could not be happening. We have also the e-commerce. Of course, I think I've discussed that. Most of you do, some of you do the online shopping, maybe in Amazon, Jumia, or other online platforms. OLX, I don't know where OLX went. Maybe. Then you have the hospitals. Again, the records, maintenance, and all those use computer networks, and other industries. So these industries are the motor vehicle industries, manufacturing industries, either small industries or bigger industries. So there's a wide range of where the computer networks are used. So in case somebody asks you what's a computer network, I think by now you should be able to explain that. What are the uses? So why do we need that computer networks? So this is just a highlight of what we may use a computer network for. Remember, it's not limited to only these. There are so many other uses of computer networks. So this is just like a summary of where we use a computer networks. So it's also not limited to these industries. There are so many other sections in almost everywhere in the world now. At least the COVID-19 thing brought the real essence of now the computer networks, because everywhere now you're required to work at home, work from home. So running also from home. So you cannot do that without a computer network. So that is always been courtesy of the computer networks. Now, there are several maybe features. We may not look at the features of a computer network, like the file sharing. They all like narrow down to the uses, the backups, the hardware and the software sharing, the security, scalability, and other features of a computer networks. Then let's look at the different types of computer networks. Now, these types of computer networks, they are illustrated on the diagram there. So we see that a computer network is simply the interconnection of computer networks. But how are they interconnected? Remember, we are doing this to enable the computer to communicate with either another computer for purposes of sharing the resources, data, or applications. So we have several types of those networks. So we have the PAN here, the personal area network. We're going to look at each network one by one. So, but mostly what the personal area networks, this is mostly within the 30 feet or 10 meters, right? So your personal space, you may be using, let's say your laptop. You have used your phone to hotspot to the laptop, or you're using your laptop to hotspot the wireless signal. Let's say you're using the Bluetooth headsets, or you have a system. Let's say you have, let's say a subwoofer or a sound system there, like maybe a home theater or something, or a digital TV. Remember these days we have the digital TVs with capabilities of wireless connections. So you can connect all those devices together. You can also have like a wireless printer. You can either connect it either through wires or the wireless. So whatever is within you, the 10 meters, be it your speakers, you're connecting through the Bluetooth headset. Maybe you have a mouse. You have wireless mouse or cordless mouse. Maybe you have a keyboard. You have cordless keyboards. Cordless means that it doesn't have a cable. So you're either using a wireless connection or through Bluetooth. You have maybe, let's say, a remote of your TV. You usually control your TV set using a remote, which is wireless, using infrared. So that's basically what you call a personal area network. Now we have a local area network. Basically, local area networks are mostly in, like, let's say, ZTech. If you happen maybe to come to ZTech main campus, you see that there is a network there. There are computers in the computer lab, there are demonstrative offices, and almost everywhere there. So within that campus, that's what you call a local area network. Maybe within a building, ZTech may be having, like, let's say, 5 floors, right? So within those 5 floors, each floor has computers. They are all interconnected. So within that building, that's what we call a local area network. Then you have a metropolitan area network and a wide area network. Maybe I can explain using the diagram right here. So the local area network, we started with the personal area network. I've explained simply the devices or the connections within, like, let's say, 10 meters or that feet within your personal space. The local area network here, you can see that we have a building, right? So inside each building, there is a network. The floor 1 has, let's say, the HR department. Floor 2, that's why you have the computer labs. Floor 3, that's why you have the IT department. So all these floors has computers. These computers are all interconnected, and now all of them are connected to what? The internet. So within each building, remember these are mostly uh, defined by the distance they are covered. So this is within, maybe we may have several buildings within a campus, right? So you have building A, let's say these are the demonstration offices, these are the classes, these are the labs, these are whichever other departments. So within each building, there's what you call a what? There's a network within each. So simply, within a campus or a small geographical area, that's what we call a local area network. Then you have a metropolitan area network. So we may have, like, let's say, the town, the nearest town to you. Maybe it's Nairobi or Mombasa, whichever other town. So all the buildings usually have what you call the local area networks. But then let's say we have a bank, for instance, and the bank within this town or within this city, they have several branches. So all those branches are interconnected. So that's what you call a what? A metropolitan area network, right? So the connections within, let's say, a city or a town. So the interconnection within which we are taking the local area network within a building, connecting to another local area network in another building, connecting to another one. So all these connections are what we call a metropolitan area network. Then let's say now we have, like, the same bank. We have one bank in Nairobi, another branch in, let's say, Mombasa or Kisumu, another branch in Tanzania, another branch in Uganda, another branch in another continent. So how we connect now these individual branches is now through what we call a wide area network. And the wide area network here mostly usually refer to, an example of a one here is the internet. So the internet, the one here can connect over different countries, let's say counties, or let's say countries, or even continents, right? So that is the range of how we define what? It's just like a hierarchical structure here. So these are the different types of what? So starting from the personal area network, your personal space, 10 meters, to a campus or a college or a business or a bank or whatever. So within that section, then you go within a city, so different branches, branch A, headquarters, such. Then you go to a different, let's say, within East African region, South African region, you can all connect to that, which is a wide area network. So these are simply the types of computer networks that are majorly used. So I think I've explained what is in our next slide, though I may just quickly go through it. So this is what I've discussed, the computer networks, the personal area network here for interconnecting electronic devices. So these are usually centered on an individual's workspace. So this workspace is usually 10 meters or 30 feet. So you have your smartphone, you have your tablets, Bluetooth enabled devices like the keyboard, the mouse, the speakers, and everything. So all of them are connected within your personal space. So they can either be wired or wireless, right? But mostly these are wireless. You can hotspot using wireless, Bluetooth here. This could be a PDA, could also be wireless. A laptop, your laptop could be wired or wireless. Mouse could be wired or wireless. Again, the printer can also be wired or wireless. So within whatever is maybe let's say 10 meters, that's what we call a personal area network. So you're supposed to know the characteristics. What are the characteristics of these personal area networks? So what are the advantages of these personal area networks? What are the disadvantages? So the moment you visualize what this one is, actually you don't need now to cram the definition, but just visualize something like this, then using your own words, you can define this, right? So whenever somebody tells you to define, or whenever you want to know the definition of the same, you don't have to go cramming everything there. Then the other connection is about the local area networks, just as I had explained. In the local area network, a simple and computer network that interconnects computers within a limited area, right? So this limited area could be your apartments, a school, a lab, university campus, or office buildings. So maybe we have a bank, we have branch A here, branch B in that. So you see that within a local area network, we have a building here. This building, let's say it has 20 floors. In each floor, we have a network of computers, and they are all connected using the devices that we talked about, the routers, the switches, and firewalls and everything. So the interconnection within this building could be one building or connected to another building. So it could be having several LANs. So basically, that's what we call a local area network. And within a local area network, again, you're supposed to know what are the characteristics of the local area networks. So what are the advantages of a local area network? How does it compare? So what are the disadvantages the same? So those are some of the things, and I've included them in your notes. Again, we have now the metropolitan area network. As I've discussed, the metropolitan area network simply covers a larger geographical area. So we are interconnecting different branches. So different local area networks within, go to the next slide for that. So this is what I see, that within building A, it is spanning several floors. We have local area networks within each floor or within the entire building. Another branch, it contains within a local area network. So we want to connect all these buildings together. So what do? This is what now we call a metropolitan area network. And from the definition here, it's a network that covers a larger geographical area. And this area could include a city or a town, or let's say county A to county B. So we are interconnecting different local area networks to form a larger area network. So it's a collection of a LAN here, collection of another LAN, connection of another LAN. So interconnecting this LAN to the other LAN, we use a metropolitan area network. Again, it may span the wide area network, which I think is discussed in the next slide. So a wide area network then extends to even larger geographical areas such as the states, the countries, the continents, and the wider areas. Then it is also usually not limited to location, so it can span through the telephone lines. We can use the optical fibers, we can use the satellites. For instance, let's say you're connecting from, let's say Nairobi to Nakuru. So we can have optical fibers. That's wide area network. We can also have satellites. So where do we use satellites? Maybe you are in Nairobi, Kenya. Somebody else is in, let's say in Europe. So what do you use? there is a satellite in space that connects these two. So a signal is sent this, then back, right? So you can use satellites. There are different types of satellites. The low orbit, the low Earth orbit satellites. There are so many different types of satellites that you can use under the one. I think you've also ever heard of the undersea fiber cables, right? So you can also use the optical fiber cables, and you're also supposed to know the advantages of these transmission medias. What is the advantage of fiber optic over Ethernet, over coaxial cables? So know the difference of these interconnections. So the moment you span over even larger geographical areas, that's when we create a what? A wide area network, just as the name implies here. Chepkiru, you're asking, talking of a limited area, do you mean like an institution? For local area network, yes. Within an institution, I don't know, maybe you've not had a chance of visiting ZTech, but I'm sure you've been within your high school. Let's maybe take an example of high school. In your former high school, there were offices, there were classes, there were dormitories. Each block, like the labs, could be having their own internet or network. There is an interconnection of their computers in the lab, computers in the administration block, maybe computers in your dormitories or whatever. So the interconnection of these computers here, this is simply what you call a LAN. So it may be limited to an institution or a campus or an office building or a branch, maybe a bank branch or whichever branch. So within each campus, that's what you call a local area network. Simply, most of them are usually defined by, limited by the distance they cover, right? Because you see now when you come to personal area networks, that's 10 meters. Local area network limited maybe within one building or two buildings. Metropolitan area network, maybe let's say several kilometers. Maybe you are in, let's say, Nairobi. You are in the upper part of Nairobi. Let's say you are on University Way. You have another branch on River Road. You have another branch in industrial area. That's what you call a metropolitan area network. Then from Nairobi, within that city, you want to connect to another city, let's say in Mombasa, to another city, let's say in Dar es Salaam, Tanzania. That one now you use what? The wide area network, or you use the internet. I hope that one is clear, Chepkirui. Now, there's what we call, next is the types of network topologies. So what exactly is a topology? So a topology simply refers to the structure of the network. So how are these components interconnected, right? If we say that all these devices can be connected using wires or wireless, how are they interconnected? What is the structure that is used, right? So these topologies are usually of several types. We have the bus topology. We're going to look at it. We have the ring. We have the tree, the star, mesh, and hybrid. You have been using maybe any one of these or all of them, maybe without your knowledge. So maybe we can look at each structure of the network. So from the diagrams there, you can see that there are illustrations of each connection. The mesh simply means that we have client A or desktop A or laptop A here. It's connected to all the others, right? So they are all interconnected. Again, what you should know is that what is the advantage of having such a topology, right? What are the disadvantages? Then the other topology here is what we call the ring topology. So we have client A here connected to B, connected to C. So they are all interconnected to one another to form what we call a ring, right? So again, we have what we call the star topology. So the star topology, you can see that there is a central device here. So this central device would be a server. Of course, mostly we usually use, we can have a switch connecting all the devices to a switch, then switch to the server, or another central powerful computer here. So all the other clients, maybe the desktops or your laptop or your phones, are all connected to one central what? They are all connected to one central device here, which could be a server or a switch. Then the tree topology here, you can see it's like the combination of the star and the bus, right, to form what looks like a tree. So within each, you can have several star topologies here, and all of them connected to one main cable here. And remember, this is resembling a bus. So it's simply like a combination of star and the bus topology. We have then what you call the bus topology. All the devices are connecting to one main cable, right? Then you have another one we call the hybrid. The hybrid is simply connection of different topologies. Maybe you could have this cable running to this, maybe this cable running to the central server there, right? Maybe this cable. So the interconnection of different topologies is what you call a hybrid, right? Just as the word implies, hybrid. So what you're supposed to know under each topology are the, maybe let's say, the advantages. If you take, for instance, maybe you can start with the bus topology here. So what are the advantages? So from the look of the topology here, of course, we see that we're using the wired connections here. So in case one of these connections, let's say this one fails, the others continue what? Functioning. So maybe that could be one of the advantages of the bus topology. But then a disadvantage could be we are connecting all these clients here or hosts to one main cable. Suppose now this cabling fails, what happens? If it happens to fail, then all the computers connected to it actually will fail, right? So you're supposed to know under each. So from the look of it, you can be able to deduce the advantage of each. Maybe you can have another disadvantage. We have a lot of cabling. You see, each computer must have a cabling to the main. So there is a lot of cabling required. Then we also likely to have what you call the signal interference. How is the signal interference coming in? This computer is sending some traffic. This one is sending at the same time. So if they happen to send at the same time, there's what you call a collision. Even though right now you have mechanisms of detecting and avoiding collision, what you call the CSMA CD, the carrier sense, what you usually call CSMA. So carrier sense multiple access collision detection, carrier sense multiple access with collision avoidance. So that is the bus topology. Maybe let's go to another one like the ring topology. So what would be the advantage? Again, the cost, it would be cheap because you just need a cable to each. So you don't have other extra cables needed in between. Could be also reliable. Maybe you could also using the cheaper Ethernet cables. You don't have to use like fiber because fiber are expensive. So you can simply implement the star using, maybe those are some advantages. But then one of the biggest disadvantage of the ring is that in case there is a failure at just one point, then the entire ring is broken. So that's one of the disadvantages. Then again, reconfiguring again would be difficult, right? So there would also be some delays. Maybe this is processing a lot of data. It is also required to process the traffic that is coming in. So before it processes the traffic that goes to the other, again, it may take time or cause delays. Maybe let's talk about, maybe let's also look at some of the advantages of the star topology. Mostly this has been used almost everywhere in cyber cafes. You usually see that all the desktops or all the computers are connected to a central switch, right? But again, then we may have, since they are connected to a central point, it's easier to have control, right? You can control all these devices from the central device here. Again, it is also cost effective compared to, let's say, like the mesh, where we need a cable to the connection to every device. Then we also mostly have high data speeds, maybe using, let's say, Cat5e, which supports speeds of 100 Mbps, megabit per second. So again, depending on the type of connection, it will depend. So the speed mostly we use mostly the Cat5e or Cat6. Cat6 supports up to 1000 megabits per second. So maybe what would be the disadvantage of each? of the star topology. So if you look at the star here, if the central server or the router here or the switch happens to fail, what will happen? All the other devices will automatically fail. So that's one of the major disadvantages of what? The star topology. Again, the cabling sometimes is usually difficult because again, the rerouting of cables and such, that could be a disadvantage to each. Again, the another advantage could be you're using the cheaper Ethernet cables. Again, you can easily reduce either the advantage or disadvantage from just looking at the topology itself. Maybe the mesh here, from just looking at the mesh topology here, of course there are two types. There are usually two types of mesh. There's what we usually call the full mesh topology and the partial mesh. The full mesh simply means that each computer is connected to all the other computers available on the network. In the partial mesh, this simply means that this computer is not connected to all of them. Maybe it's connected to this one and this one alone. This one is connected to two others. So that's there are usually two types of the mesh topology, the full and the partial. Again, let's maybe look at the advantage. And the advantage is mostly usually relative, usually comparing this topology, maybe let's say to the star. Here, let's say in case this one fails, there's a connection that you have connected, we can always have a second connection going to this, then back to this. So there's some sort of reliability in case of a link breakdown. So one link breakdown will not affect like the other communications, because if this one fails, then this one continues. If this one fails, then to this other communications still continue. So again, there is fast communication between the nodes. They are directly interconnected to one another without going through any intermediaries. Then also, it's easier to maybe reconfigure. So you can easily add another device here without interfering with other devices. And that one we are comparing to this. If you happen to add another device here, you have to like to disconnect first, then add, right? Again, in star, it's also easier to reconfigure because you just add. This one is also easier because maybe you can just add, right? And so the advantages and disadvantages here, as I said, are relative. So what could be the disadvantages of mesh topology, for instance? Of course, maintenance for this one is, of course, high, right? The cost is high because we need a cable to each, assuming you have 10 computers here. So you need 10 cables, right? So 10 cables means, take for instance, a laptop or a desktop. They only have one port for what? For the Ethernet cable. That means you need a switch for every device, right? So that you may have, right, say like an 8-port switch, so that you can connect to the other 8 devices. So it would be, the cost would be high because of the cost of transmission media and some other network devices we have to manage. Then there is also what we call the efficiency. There's a lot of redundancy. You see that let's say we have computer A here. We are connecting to, we can get access to computer, let's say B here, through this connection, through these two, through this one here again. So that's what we call the redundancy. And the redundancy here is going to reduce the efficiency of a network, right? Before there is calculation of which is the best route to use, right? So the efficiency of a network is reduced. So make sure you can understand or rather illustrate each topology using an illustration as is here. Maybe define it, right? Know the advantages, one of two or each, and know the disadvantages of each topology. There's the other topology here, the hybrid, which I think I had explained. The hybrid is simply, as I said, a combination of different topologies. We can see that we have the tree. We have the tree topology on this side. We have the bus topology on this side. We have the ring. This is the ring here. Maybe you could also have the star connected. So again, star connected to a device. We have another device there. So the combination of various topologies, this is a star, is simply what you call a hybrid topology. So the different links in the mode of the transfer of the data. So what again would be the advantages of such a topology? Of course, number one, there is what you call, it's of course reliable, right? What do we mean by reliable? If there is a link breakage or some device breaks down at any part of the network, it will not affect the functioning of the other networks. Let's say there is a breakage of this link here, right? So it will not affect the working of the functionalities of other devices here or networks. Let's say this computer breaks down. It is somehow like independent on its own. So it will not affect what? The working or the functionality of the other parts of the network. So that's one advantage of the hybrid topology. Another advantage could be the scalability. Scalability simply means that you can expand at any one point. You can choose to include other computers or other topologies, or you can be able to scale either up or down. Scaling up simply means you can add other topologies. Scaling down means you can do away with a topology, right? So that's one of the advantages of this topology. Another could be the flexibility. You can design according to the requirements of an organization. Let's say this is an organization, it has 3 floors. So the first floor, we are implementing what? The tree topology. Second floor, we are implementing the bus topology. Third, maybe the star. Fourth, so there is flexibility. You can go to the 5th floor and choose to include any other topology. So according to your requirements. So the requirements are the ones which are dictating which topology to use. Again, this is also effective because again, we are minimizing the effectiveness. Maybe it could be based on how we are minimizing the weaknesses within the network. The link breakages, the device breakages, are then going to affect the functioning of the network or the device. Again, if you look at some of the disadvantages of this topology, from the look here, of course, you know that it is costly because at every point we need devices like, let's say, switches, because here we need a switch before we move out. We need a switch here, we need a switch. Or maybe at some point you need a router if you're spanning over different floors. The cablings, they're also expensive, right? So it's also costly, and it's also sometimes complex. The design itself is complex. So again, it may also be costly, matters of cost, because we need a lot of the network devices that I've said. We need a lot of the cabling spanning different floors, the devices like the switches, because we must need a switch at every topology, right? We may also need a router, probably. You may also need like a firewall, right? So the cost of all these devices eventually brings the cost of the entire topology up. So those are the different types of the topologies. And I think that's the end of this presentation. So if you have any question, you can ask regarding this simple introduction of computer networks. So we simply looked at